So here we look at Grignard addition to aldehydes and ketones. This is a reaction that is going to behave very similarly to another reaction, the hydride addition to aldehydes and ketones. Now, in any Grignard reaction, there's going to be two pieces to it. There's the formation of the Grignard and then the addition of the Grignard. But overall, what's going to make this reaction valuable is it gives us a new carbon-carbon bond, and it converts our carbonyl into an alcohol. So the Grignard reaction is credited to Victor Grignard around 1900, and this reaction was so quickly found to be useful that just 12 years later, he won the Nobel Prize in Chemistry. So as we said, there's two pieces to this reaction. The first is you have to make the Grignard reagent. Making a Grignard reagent requires the use of an alkyl halide and magnesium metal. And the magnesium does what we call an insertion reaction, which we won't go into the mechanism of, but the magnesium will insert itself between the carbon and the halogen. And we can do it with very simple reagents, just like bromomethane. Isopropyl is another common one. And maybe the most common one, in fact, we see it quite often in undergraduate lab experiments, is to take bromobenzene and add magnesium to make the phenyl Grignard. Now, once we've made the Grignard reagent, at that point, we can add it to an aldehyde or ketone. So if we look at this one of methyl Grignard with acetone, basically in a Grignard addition, the Grignard reagent acts as if it's a carbanion. It's not a full carbanion, it's just a partial negative, but to a large extent, it functions as if it is a carbanion. And so that carbon will attack the carbonyl, shift the electrons up onto the oxygen, gives us our oxygen anion, and a new carbon-carbon bond. At that point, we just quench the reaction with water or acid, and we form our alcohol. And so, very, very straightforward reaction. You can use pretty much any ketone and any Grignard as long as you can make it. So here we see an example of the isopropyl Grignard with cyclohexanone. Or we could do this with an aldehyde as well. So here's benzaldehyde with phenyl magnesium bromide. And again, we're going to form a new carbon-carbon bond between the carbon of the Grignard and the carbon of the carbonyl. So very useful synthetically. Again, it makes a new carbon-carbon bond for us. We can bring in something as simple as a methyl, an aromatic ring, or many other groups. And in addition to that, it then leaves us with an alcohol that we can use to do further reactions from there.